Hey there, ladies and gentlemen, boys and girls. Today we're going to talk a little bit about electrical energy. Moving on to our next form of energy here. We're going to talk a little bit about electrical energy. Obviously, this is something you deal with your everyday life. You're literally watching this on some sort of electrical device that is using a battery that runs off electrical energy. So this is obviously a very intuitive or a very common thing that we are all very familiar with these days. So we're talking about just the very, very basics of electrical energy. You can literally spend an entire semester talking about electricity and electrical circuits and all that stuff. We're going to talk about the fundamental principle of all electrical systems, whether it's the circuits that run this video, through the Chromebook I have, or whether it's the power grid that runs an entire city. It all runs under a couple simple principles, and one of them is what we call Ohm's law. All right, and so that's what we're going to talk about today. Just that very simple principle. Well, first of all, what is electrical energy? We talked about all energy is basically either potential or kinetic. All right. And so when we talk about electrical energy, we're talking about two things. We're talking about electrical potential, which we'll talk a little bit more in a moment, which is called voltage. And we're talking about, excuse me. Sorry. All right, sorry. We're also talking about electrical energy. We're talking about kinetic energy, but kinetic energy of electrons. All right, so kinetic or electrical energy is literally the kinetic energy of electrons. You'd think I'd get better at writing with this thing so far, but all right, it's the kinetic energy of electrons. There's bigger, fancier definitions than that, but we're just going to keep this kind of simple. All right, basically it's how much electrons are going to move. All right, and there's a couple ways that we measure that. All right, so first of all, when we measure how much electrons are moving, how much kinetic energy you have, what we're really talking about, and what we're really going to be talking about, is the relationship between these three things down here. Oh, I can't really see the bottom one there. Sorry. I don't know how to get this without bringing it back. Current, voltage, and the bottom one says resistance. Sorry, my little drawing bar is in the way. All right. Current is basically I feel like is the biggest one. The other ones are just depend on how much current there are. Current is how much flow of electrons there are. Again, there are bigger, fancier definitions than these, but I'm going to keep them kind of straightforward. All right. So it's the flow of electrons. Easy way to think about that is like a river. All right. The flow of a river. How much does the water flow through it? Is it a fast flowing river or a slow flowing river? The more current we have, the greater electrical energy, because more flow means more motion. More motion means more kinetic energy of electrons. It's these electrons, and then when they're flowing from, remember, we have the nucleus, and then around it we have electrons. And what's flowing is literally electrons are, depending on who you ask, because there's different theories on how this works, the electrons are just flowing to the next atom. And they flow from one atom to the next, and they move from one atom to the next. What causes that is something called electrical potential. And electrical potential is what we call voltage. All right. Voltage is basically is electrical potential energy. That's actually what voltage really is electrical potential energy. Remember, when we talked gravitational mechanical energy, the more I lifted this up, the more gravity could cause it to move. So voltage potential is basically the potential energy that could cause electrons to flow. All right, and it's caused by positive buildup of negative positive charges. All right, think of it this way, just kind of as an easy reference. We know atoms have protons and neutrons. Protons are positive, mass of 1 in the nucleus, mass is fun. Protons are positive, electrons are negative. When they get closer together, they're more likely going to attract to each other. You can also say the same thing about if you put two negatives together, closer together, the more they want to repel, the more they want to push away. And that is causing potential energy to be stored up. For the sake of what we're going to be doing in here, we're going to call potential energy. Potential energy we call voltage. And basically what it does is it allows the amount of push of electrons. All right. As I've just been talking, you see that it's actually a much more complicated thing than that. But that's the big picture, is basically how much it's being pushed by having how much potential energy. All right. This is the potential energy portion of electrical energy. Is that potential energy? All right. The last one is, so think about voltage is, if you're thinking about a river, right? River flows down a stream or down a hill. The steeper the hill, the more voltage, the more flow there is. A very almost flat hill, the water's going to flow very slowly. It's very low voltage. Like a AA battery is 1.5 volts. It's a very flat hill. It's a very low flow of electrons. Some batteries can be up to 9 volts. That's a little bit steeper one. Car batteries can be 12 volts. That's a little more, or up to 20 volts. All right. That's a steeper and steeper hill, creating more and more push, more and more voltage. All right. And then that leads us to our last one there. So if we have a river that's flowing on a hill, last thing is there's probably going to be rocks in the way that is going to slow down the river, stream or sticks and logs and things like that. All right. And that's what we call resistance. It's hard to define resistance simply without using the word resistance, because it's kind of what it sounds like. It's wow, how do I even define it? All right. We'll just call it slows down electrons. Basically what it's doing is slowing down the flow. It goes opposite of current. All right. And each one of these, their relationship together is what we call Ohm's law. Ohm's law is the relationship between these three things. So we have different units for each one of these real quick. I forgot to mention when I start going through this. For current, we measure it in something called amps. We abbreviate with an A. For those who are musically inclined and have ever used an amp, right? What that is measuring is amount. You crank it all the way up and it measures how loud things are, is because it's determining how much flow is going through it. Something, when you crank it all the way up, you're allowing a lot of amperage, or the ampere, or a lot of flow of the electrons to make it very loud. The voltage is measured in, as you might imagine, volts with a capital V. Lowercase v is velocity. And then resistance is measured in, named after the man who created this kind of law, is called the ohms. It's measured in ohms, or ohm. And then its abbreviation looks a little different. It is the omega. Kind of looks like almost like a little balloon. All right. It's a Greek letter omega. That is the units for resistance. All right. So, like I said, the relationship between these three things is what we call Ohm's law. It is how these three things interact. All right. And that's what you guys were asked to find, that relationship using that simulation. So we have the push, right? We have the resisting caused by, so this would be the voltage. Here's the resistance. And then how much it does that determines the flow. So it's a relationship between these three things. It's a relationship between voltage, resistance, and how they both affect the flow. Who's doing more? Is there more push than there is resistance, or is the resistance stopping how much there is pushing? All right. And that's what Ohm's law is. And so you guys got to collect some data. All right. And your guys' first one, where you guys picked oh shoot, which one did you guys do first? You guys did voltage and current. All right. Where you're trying to see as I increase the voltage, what happens to the current. That should have been a pretty easy one. That is a very straightforward relationship. You should have seen it gone up. So the more push I provide, the more flow there is. All right. And so we see a very positive constant relationship on this one here. So we know that voltage current is directly related to voltage. All right. And then you guys, let me move my face. Then you guys collected data on, actually, no, I don't want, I want to be back up here. Sorry, you guys collected data on the relationship between current and resistance. So assuming I keep the same amount of push, right, what's going to happen? As I increase the volt or resistance, you're going to see a decrease in the current. Not just a negative relationship, but a changing relationship. And so you see that actually current, and this is kind of remembering back to what we did with Newton's laws, is inversely related to resistance. And so now we have our two relationships here. Current is directly related to voltage and inversely related to resistance. And so now we can put those two things together. Sorry, I don't know if I paused my video or not. Anyway, let's just keep going. We could put those two relationships together to create voltage, or the Ohm's law, where current in amps is equal to the voltage of the system divided by its resistance. That's it. That's Ohm's law. Is that mathematical relationship between those three variants? So you could also, you could rearrange this formula and say that voltage is equal to current times resistance. Or you could take this formula and rewrite it and say that resistance is equal to voltage divided by current. That's just rearranging the formula, but this is our main one here because this one here is our main one here. That is Ohm's law. It is a relationship between current, voltage, and resistance. If you increase the voltage but keep the resistance the same, if this number gets bigger, then this number also gets bigger. All right. And if I keep that, or if I keep voltage the same and I increase this number because we're dividing by a bigger number, this number goes down. All right. That's the inverse relationship. So let's kind of apply that real quick, and then that will kind of finish us off for today. Yeah. So if I were going to apply, so here's a circuit, right? Every material in a circuit causes resistance. Even wires, even some of the best wires create resistance. All right. So we're gonna keep this nice and simple. All right. So we have a battery that's creating an electric potential or voltage of 18 volts. The lamp over here is creating 3 ohms of resistance, and I want to know what is the current. All right. All right. So I would have to figure out, I want to know what the current is. The voltage is 18 volts divided by 3 ohms, which then would be 6 amps. That's 6 amps. Now, if let's say I doubled, all right, my voltage, I doubled my push. All right, take a second, think about what would happen if I doubled my push. All right, in that case there, if I turn this into 36 volts. I put an extra battery in there or something like that. What I'm going to do, I just turn this into 36 volts divided by still the same amount of resistance. Now I have 12 amps. I've increased it. Now, when you do that, when you create that, you're creating more flow. You're actually creating more friction. You're creating more heat. You can overheat a circuit, and you can overwhelm a bulb and burn it out, break it out. So it's really just about playing the formula. You can go on much deeper things about this, whether it's just a simple battery wire bulb circuit or the circuitry that's working my laptop. It's about this relationship. You can't have too big of a battery for a circuit. You can't have too little. Doesn't do that much for you. Every circuit material provides resistance, so you got to find out how much that is to give you the right amount of voltage, to give you the right amount of current. It's all about that relationship. All right, I'm going to end it there because I know this video is getting a little long. So that's electrical energy, flow of electrons. Ohm's law, which is the foundation of it, is that relationship between the current, voltage, and resistance, and how those three relate to each other determines how much current there's going to be. All right, go back in the video if there's anything you forgot or didn't add to your notes. Otherwise, good luck, and may the science be with you.